Hi, everyone. Thanks so much for the invitation to speak today. I want to start with kind of a message of hope. I actually heard some students behind me already thinking this was going to be depressing. So a message of hope courtesy of Oscar the Grouch. For anyone who's not familiar, Oscar is a character on Sesame Street, and he lives in a trash can. And Oscar says it's called garbage can, not garbage cannot. And so, I recognize that this can be kind of a depressing topic at times. But, I, for one, am optimistic and have faith in humanity to address this issue. So hopefully, this talk is informative and maybe leaves you inspired to want to get involved in efforts to address marine debris, and hopefully doesn't leave you in kind of a deep pit of despair or something like that. So I'm really just going to kind of brush the surface of this topic, but I'll start by talking about some background on the Noaa Marine Debris Program, sources of marine debris, dig into plastics in particular, talk about the physical, chemical, and socioeconomic impacts of debris, fate and transport of plastics and other type of debris once it enters the marine environment, a little bit about solutions, and talking about the California Ocean Litter Strategy. So NOAA, the National Oceanic and Atmospheric Administration, is an agency within the Department of Commerce, and we have 6 different line offices. So NOAA has the National Weather Service, the National Marine Fisheries Service, the Office of Oceanic and Atmospheric Research. The National Ocean Service is where the Marine Debris Program sits. The National Environmental Satellite Data and Information Service, and then the Office of Marine and Aviation Operations, which are our NOAA Corps officers that operate the NOAA vessels and aircraft. So marine debris-related legislation at the federal level. So in 2006, the Marine Debris Act established the NOAA Marine Debris Program and designated us as the federal lead on addressing the issue. And it's important to point out that we're non-regulatory and we don't have any enforcement authority. But then the Marine Debris Act was amended and in 2012 passed again, and so those 2 laws together provided the following mandates for NOAA: to identify, determine sources of, assess, prevent, reduce, and remove marine debris, provide national and regional coordination, provide grants for marine debris projects, conduct outreach and education, reduce the adverse impacts of lost fishing gear, and address severe marine debris events. Then late last year, the Save Our Seas Act was signed into law, and so that reauthorized our program at the same authorized appropriation level of $10 million and added mandates on interagency collaboration on outreach and promoting international action to address this issue. So we organize our work to address these mandates under kind of 5 main program pillars. First and foremost, prevention to reduce debris at the source, research to better understand and quantify the impacts of debris, removal of material that inevitably makes its way into the marine environment, regional coordination, and emergency response. And so today I'll talk a little bit about the first 4 and less so about emergency response, but this includes coordinating the federal response and supporting state and local agencies on addressing debris generated by major hurricanes and storms on the East Coast, or a local example, the debris generated by the earthquake and tsunami in Japan in 2011. So we're a small, regionally distributed program, so there's about 23 of us nationwide. I'm the only staff member in California. I'm based up in Oakland. And about half of our team is at the headquarters office in Silver Spring, Maryland, outside of Washington, D.C. I don't know if there's any Nats fans in the crowd, but they beat the Dodgers last night, so this is our team of Nationals fans. And because we're such a small, regionally distributed program, we really rely on our partners and especially our grantees to implement projects on the ground. So we have an official, very bureaucratic definition of what marine debris is, but essentially it's any solid man-made material that's in the marine environment that's not meant to be there. And so it can range from small pieces of microplastic to consumer debris, lost fishing gear, or large abandoned and derelict vessels. And the sources of debris can broadly be divided into land-based and ocean-based sources. So land-based sources are the majority of the debris that we find because that's where most human activity occurs. And they can include littering and illegal dumping, poor waste management, stormwater discharge, and of course, natural disasters. So this is an image of debris from the earthquake and tsunami in Japan. This photo was taken off the coast of Japan really soon after the event. And then, of course, ocean-based sources of debris are any human activities at sea and can include commercial and recreational fishing, abandoned and derelict vessels, research equipment, offshore oil and gas, and cargo ships. So this image is of one of many shipping containers that was lost in the Monterey Bay, I believe back in 2004. And from my understanding, they're in a location where it's not really feasible to actually remove them, but there's some monitoring activity going on to better understand the habitat impacts and changes in the diversity of the species that are living around it. And so everywhere we've looked in the ocean, we've found plastics or other types of marine debris. So that includes incorporated into Arctic sea ice, stranded on really remote islands in the North Pacific, and at the deepest depths of the ocean. And it's an issue here in California as well. This is kind of an iconic image from Buyuna Creek, which is in LA. And you can see this was taken soon after a major storm, and you can see just a tremendous amount of food and beverage packaging and other consumer litter accumulated behind this net. And the conversation is usually focused around plastics because that's the majority of what we find when we do monitoring studies and look at the types of debris in the environment. And it's not really surprising because plastics, of course, are used to make any number of items that we use in our everyday lives. They're cheap to produce, and just by virtue of the way that they're designed, they persist in the environment. So they don't actually biodegrade, but they actually fragment into smaller and smaller pieces in the environment, and we call those microplastics. And it's interesting to look at trends in plastic production and disposal over time. So here the figure is going from 1950 and projected out to 2050 with million metric tons on the y-axis. And the black line here is showing primary plastic waste generated. The red is how much of that has been discarded. The green is how much has been incinerated. And then the blue is how much plastic waste has been recycled. And you can see where we are here in 2019. And the best estimate is that from 1950 to 2015, 8.3 billion tons of plastic have been manufactured. And so of that, 30% is still in use, so that's not reflected in this figure. About 60% has been discarded, so that's either landfilled or lost in the environment. 10% has been incinerated, and less than 10% has been recycled. And it's also interesting to look back. In 1972 was the first published report of plastic in the ocean, and this is when these trends were really just kind of starting to increase. So looking forward, the projections into the future, I think we have our work cut out for us. And when you look at the plastic waste that's being generated according to industrial use sector, here the take-home message is really packaging. So this big, lighter blue chunk here at the bottom reflects packaging waste, and some of these other types of categories include textiles, industrial machinery, consumer products, electrical, building and construction, and transportation. And when we look at the debris that we're actually finding in the environment, it mirrors the waste that we're generating. So the infographic here in the middle is from the 2018 International Coastal Cleanup. So this is global data on the most common debris types that were found during this event. And with the exception of the number one most common item, cigarette butts, the rest of it is really related to its plastic food and beverage packaging, and specifically single-use consumer items. So these are all things that we might use for 15 minutes and then throw away, and they persist in the environment. And back in 1955, Life magazine promoted this kind of throwaway living as a way to cut down on household chores. But now I think that we're looking at it a little bit differently. And so we know that the trash that we're generating is what becomes marine debris. And I just really like this graphic from the Santa Clara Valley Urban Runoff Pollution Prevention Program on all of the different pathways through which trash can enter the environment. So, there can be litter from cars and trucks and uncovered truck beds, garbage and recycling bins, whether it spills on collection day, scavenging, overflowing bins. Of course, pedestrian litter can get into creeks through storm drains, and illegal dumping. And so we refer to all of these as points for leakage through the waste management system. And I think the take-home message from here is that just because something is disposed of properly doesn't mean that it will never become marine debris. So just by virtue of generating waste, we're all contributing to this problem. So how much plastic is actually entering the ocean? Our best estimates come from this paper by Jenna Jambeck and others in 2015, and they estimated 8 million tons of plastic enter the ocean every year, and so that's equivalent to about a dump truck every minute. And this data is based on per capita consumption or use of plastic or generation of plastic waste in these nations, as well as the waste management systems in these countries. And the darker shaded regions are where we think that more of the plastic is entering the ocean, and that has China, Indonesia, Philippines, and Vietnam topping the list. So when you look at the data this way, it kind of looks like it's really a problem coming from Southeast Asia. But when you look at the data a little bit differently, so here the size of the pie chart indicates the total amount of plastic that's being produced in these nations, and the red sliver is the amount of that that's mismanaged. So the US here, we have a pretty big circle, but we do pretty good with waste management. But we have, of all of these nations, the highest per capita creation of plastic waste, and we're actually the only developed nation in the top 20 list when you rank these nations according to how much plastic waste they're generating. So, when you look at the data this way, it tells a little bit of a different story, especially considering that many of those Southeast Asian nations were places where historically we've sent a lot of our plastic waste for recycling. So, I don't think that the US is off the hook on this by any means, and in fact, we have a responsibility to lead by example. So it's obvious that this is a global issue, and it's being recognized as more than just an aesthetic issue, but there are known impacts from this debris in the environment. So here, I will ask you to kind of channel your inner Oscar the Grouch as we walk through some of the known impacts. So starting with physical impacts, wildlife entanglement is an issue that I think, especially here on the West Coast, with the recent whale entanglements, specifically in crab fishing gear. This is an issue that's gotten a lot of attention. And we know that hundreds of different species are impacted, and this can inhibit growth and mobility. But it is really hard to tell the difference between an entanglement that occurred from lost gear, which would be considered marine debris, or active fishing gear. But what we do know is that any programs that are trying to remove gear once it's lost in the environment or reduce the likelihood that there will be entanglements can help address this issue. Ghost fishing is a phenomenon where lost gear can continue to capture both target and non-target species. So this is an image of a green sturgeon in a recreational Dungeness crab trap in Northern California. And we have a lot more data from the East Coast. So there were a series of studies that Noaa funded looking at crab gear in the Chesapeake Bay, so both the Maryland and Virginia portions of the bay. And they estimated that the kind of standing stock of lost crab gear is 85,000 traps, each of which can catch up to 50 crabs per season. And they looked at the benefits of 6 years of a removal effort, so going out after the end of the season and recovering lost gear, and estimated that 6 years of that program led to a 38 million pound increase in crab harvest. So by removing the lost gear, you're reducing competition for that, for the crabs, and that had a market value of $33.5 million for the fishery. Ingestion is another type of physical impact, and this is a turtle that swallowed a balloon, and you can still see the ribbon coming out of its mouth. And so we know that plastics and microfibers are ingested by hundreds of different types of species, and size really matters. So for the smaller stuff, there's evidence that it can translocate from the gut into the liver and other organs and actually cross the blood-brain barrier. And there's evidence that this can have effects on both growth and immune response. And of course, habitat destruction, so large items like lost nets can abrade and smother coastal sensitive habitats like the coral shown here. And this is something that we're actually interested in getting more research on to better be able to quantify the impact of fishing and other types of marine debris on habitats, so that when we have compensatory mitigation settlements for things like oil and chemical spills, we can incorporate more lost gear removal efforts into those settlements to recover the resources that were lost. And of course, invasive species. So marine life can attach to marine debris and travel to areas where it otherwise wouldn't have reached. And this is an image of one of the Misawa docks that was released during the tsunami in Japan and washed ashore on the Oregon coast, I think over a year later, and there were hundreds of pounds of marine life removed from this dock. The second category is chemical impacts. So given the chemical and physical properties of plastic, it's an attractive surface for persistent organic contaminants that are present in seawater to absorb onto. So these are things like PCBs and DDTs. And there are also additives within the polymer matrix itself that can leach out. So these are like the plasticizers and flame retardants. So this creates what's called kind of a cocktail of contaminants associated with plastic debris in the ocean. And there are still a lot of questions about the significance of plastic as a vector for exposure to these contaminants compared to other sources, as well as a lot of effort going into trying to understand what are the population level impacts of this. But we do know that the polymer type, the size, and the shape of plastic can affect toxicity. So there was a recent paper published by Chelsea Rockman and others in Environmental Toxicology and Chemistry, which argues that we need to look at plastics not just as the general kind of category of microplastics, but really as a diverse suite of contaminants, similar to how we do for metals or pesticides. So plastics can come in any number of polymer types, which have different additives. They can come from primary microplastics, which are things like pre-production pellets or nurdles, or micro scrubbers in personal care products, or they can be secondary products from the breakdown of larger items. They can have various sizes, morphologies. They can be fibers, fragments, films, or foams, have a number of different colors, and attract different persistent organic contaminants. And so then lastly, the socioeconomic impacts of marine debris. First, hazard to navigation. So vessels and other large items can block navigation channels and be a safety hazard and risk to navigation. There's downtime associated with vessel repairs. So if a vessel becomes entangled in fishing gear or other kind of marine debris, there's a real cost associated with those repairs. And then lastly, tourism and recreation. So we have funded a series of studies which looked at Orange County in addition to some other parts of the country. And the first study was looking at recreation. So the economists did a survey of Orange County residents and were asking about their decision making in terms of where they go to the beach. And they found that residents are traveling farther to get to cleaner beaches. So this went into an economic model where they estimated that reducing marine debris by just 25% on Orange County beaches could save residents $32 million a year. And then a follow-up study we did looking nationwide in terms of tourism found that eliminating marine debris altogether in Orange County would increase tourism spending by $187 million and add 1,900 jobs to the local community. And so the fate and transport of plastic and other marine debris once it enters the marine environment is really essential to understanding and quantifying the impacts. So this is a figure from a 2017 paper, which is kind of the mass balance of plastics in the ocean. So of course there's inputs and potential outputs, and these squares are showing the different reservoirs. So plastic can be stranded on coastlines, floating at the sea surface, incorporated into sea ice, ingested by biota, suspended in the water column, and incorporated into seafloor sediments. And of course, there are, these arrows signify transformations and pathways between all of these reservoirs. Adding a little bit more detail, some other sources that have recently gotten attention include agriculture and sewage sludge that's applied to fields. So both, the plastic sheeting, and I recently learned that there's actually like plastic coatings on some seeds, which people have found. Wear from tires, so tire fragments have been documented in a major study that was just published coming out of the San Francisco Estuary Institute in San Francisco Bay. There they also looked at the relative significance of wastewater treatment effluent and stormwater in terms of microplastic load going to the bay. And they found that stormwater is 300 times more significant than the treated wastewater. On the positive side, they also found that rain gardens can capture up to 90% of microplastics in stormwater. And of course, atmospheric transport has also recently been found that microfibers and other types of small plastics can be transported through the atmosphere. And so in recent years, there's been this discussion in the community about where is the missing plastic, because when we look, so overall, there's a general lack of data on microplastic concentrations in each of these reservoirs, but we have the most data at the sea surface. But when we compare that to our best estimate of 8 million metric tons entering the ocean every year, we can only account for about 1% in the surface waters. So this has been an area of active research. And just recently, earlier this year, Anela Choi and others, it was a group from Mbari and Monterey Bay Aquarium, did some depth profiles for microplastics here on the left panel. And they also looked at plastics within these larvation sinkers. So these larvations have these mucus nets that capture particles for feeding, and they can also capture microplastics. And so when those nets, eventually they become clogged and released, and so they looked at relatively how much plastic they were finding at different depths from these sinkers and saw an overlap. So the microplastic had this peak kind of, just below the mixed layer, as did the larvation sinkers. And so it indicates kind of this like biological pump for microplastic, and that the water column could be a major reservoir and a potentially where some of this missing plastic is. And kind of, wrapping up the really scientific focused portion of my talk, just want to recognize how much this field has grown in recent years. So I, started working on the issue back in 2010 when it was a manageable number of papers coming out every year, and that has, near doubled every 2 years since then. And the 2019 data is really just off the charts. So, it's really challenging to keep up with the literature these days. But it's also it's nice that there has been this much attention drawn to the issue. And Noaa co-hosted the 6th International Marine Debris Conference last spring down in San Diego, and there was a State of the Science panel there where a few different data gaps were identified. And so those include identifying local entry points and interventions for debris into the ocean, again, kind of figuring out where this missing plastic debris is, and better understanding the fate of both the plastics and the associated chemicals. determining ecologically relevant impacts of marine debris. So a lot of the studies that have been done have been in the lab and have used higher concentrations of microplastic. Identifying impacts to human health and food security. And then lastly, improving methods for quantifying and characterizing microplastics in different matrices. So kind of shifting gears to solutions. This sort of inverted pyramid has different categories of ways that we can address this issue, from sort of the longer term, more effective solutions at the top to the shorter term sort of Band-Aid fixes at the bottom. So at the top, source reduction and turning off the tap is the most effective way, and this can include changes in product design to either use less material, maybe use alternatives to plastic, reduce the impacts of materials once they enter the ocean, and really just kind of make it easier for consumers to make good, well-informed choices. And then second, behavior change. So this is really focused at raising awareness and reducing the amount of waste that we're generating in the first place. So moving down from source reduction, improvements to waste management to capture trash on land before it enters the ocean and disperses. And then lastly, removal of debris that makes its way into the environment. So I have kind of a few examples from these different categories, starting at the bottom with removal. See, here's another one of our Nats fans. So Noaa, every year we have a marine debris removal grant opportunity, which is focused on medium to large accumulations of debris that are affecting Noaa Trust resources. And since the beginning of our program in 2006, we've funded more than 100 different projects and removed more than 38 million pounds of debris. And one example of a project that recently wrapped up was with California State University Channel Islands, and they were accessing some really remote shorelines out on Santa Cruz and Santa Rosa Island, where you have to hike in and hike down these cliffs and then remove all of the debris in these frame packs. They call it Marine Debris Boot Camp, which I'm proud to be a graduate of Marine Debris Boot Camp. And in some, I think over some like 15 different trips, they removed more than 6,000 pounds of debris. And at the same time, they collected really valuable data on the types and abundances of debris to kind of help drive and develop a more efficient removal program moving forward and to better understand the sources of the debris that they're finding. And in terms of waste management, this is something that Noaa doesn't really get involved in, but back in 2015, the California Water Board passed these trash amendments, which were really groundbreaking and the first of their kind for the US, where they were actually requiring within the MS4 permits, so the municipal separate storm sewer permits, requiring permittees to address trash that's larger than 5 millimeters. So it kind of, the trash policies sort of provide various options for municipalities and other permittees to take, including education and passing bans or other policies to address common litter items. But it is going to result in the installation of a lot more trash capture within the stormwater systems in California. And that can include these kind of inline netting devices, these screens on storm drains, and these underground, we have, I think there's almost a dozen of them in Oakland, and there are these big underground cylinders that are like 12 feet in diameter, and they essentially allow the stormwater to pass through and capture and collect the trash in the stormwater, and then they bring vacuum trucks to remove that a couple times a year. So like I said, this is really groundbreaking and exciting, and there's a lot of work going into developing monitoring protocols to be able to measure the effectiveness of this, but it is going to cost municipalities a lot of money. And another example that I really just love, and this is from the Inner Harbor in Baltimore, is Mr. Trash Wheel. He actually has a couple friends now. I think they're Captain Trash Wheel and Professor Trash Wheel. And essentially, it's just this solar-powered conveyor belt, and so the debris, it captures both woody and anthropogenic debris, is all funneled onto this conveyor belt and into a dumpster on the back end. And the great thing about it is that it's just created such a following in Baltimore, and it's just such an opportunity for raising awareness. So as opposed to, the in-ground stormwater trash capture that people aren't even aware exists or that their taxpayer dollars are paying for, this is really, really kind of obvious. And the Ocean Protection Council in California has actually recently awarded some funding to bring one of these to Newport. So they're expanding to other parts of the country. He has a good Twitter following too, if you follow Mr. Trash Wheel on Twitter. So yeah, just kind of going back to this figure, I wanted to point out that each of these points of leakage for trash through the waste management systems are opportunities for trash capture. And then source reduction. So changes in product design and material science in terms of consumer materials isn't really part of Noaa's mandates. But we do, through our Fishing for Energy partnership with the National Fish and Wildlife Foundation, Covanta Energy, and Schnitzer Steel, support projects for gear innovations for fishing gear to either reduce the likelihood that it'll become lost or minimize the impacts when it is lost. And there's a group based, I think, up in Palo Alto, Blue Ocean Gear, who was a recent grantee, and they developed these smart buoys, which are basically a tracking system for fishermen, and they were working with the Dungeness crab fishery to develop these, but have since been testing it with other fisheries. And essentially, it'll alert fishermen when their gear moves within a certain radius from its original set location, which can indicate either your gear is about to be lost, go recover it, or even potentially that there's an active entanglement taking place. So they're continuing to try to kind of tweak it and make it, decrease the cost to make it really realistic for fishermen to purchase and implement. And in terms of behavior change, we have a prevention grant program that's really focused on raising awareness and creating lasting changes in behavior. So focused on really reducing the generation of waste in the first place. And another recent grantee up in the Bay Area was the Clean Water Fund, and they had this Rethink Disposable project working with food businesses where they had done some street litter monitoring within the Bay Area and found that 67% of what they were finding was food and beverage packaging. So they went to the source and have been working with food businesses on a voluntary basis where they go in and they look at all of the different single-use plastic or single-use disposable items that are being used, make recommendations for changes, and then help the restaurants implement those changes and help them track the cost benefit over time. And so they're finding that for these small mom and pop businesses, they're saving thousands of dollars a year by making these changes. So it really, it makes not just sense from a sustainability standpoint, but also good economic sense. And they're continuing to expand and are getting contracts with different cities to work with a number of food businesses and other kind of institutional dining. And all of these solutions or efforts to address marine debris can be more effective with good data. So Noaa developed the Marine Debris Monitoring and Assessment Project, which is a citizen science program for shoreline debris monitoring. And it's really targeted at developing data sets which can help address local debris issues through measuring the effectiveness of new policies or identifying targets for mitigation. So it's a citizen science program. We have protocols and an online database and ask for surveys to be conducted on a monthly basis. And so, the data set continues to grow, and we've almost hit 1 million items being entered nationwide. And in addition to monitoring data, the development of regional marine debris action plans can help improve coordination among groups that are addressing this issue. So this is an effort that we've developed these action plans in 9 different regions of the US. And it helps to kind of bridge federal efforts to local level priorities and initiatives. So here we partnered with the California Ocean Protection Council and we hosted a series of workshops for stakeholders and published this strategy back in 2018. And some kind of goals that we had going into the effort were to update a strategy document that the OPC created in 2008, which was really focused on state agency actions, but we expanded that to include actions that various stakeholders can contribute to. We hope to improve coordination among groups that are doing marine debris work and galvanize new interest in addressing the issue, help us track progress over time, and then lastly, to inform decision makers and funding organizations. So, speaking kind of from the Noaa side of things, we do prioritize our funding opportunities for projects that are identified in these strategies. And in terms of what's actually in the document, there's 6 different goals and 64 specific actions or projects identified under each, or in total. And there is a real emphasis on source reduction. So the first goal is focused on policies and incentives of common ocean litter or marine debris items at the point of sale. The second goal is focused on this concept of extended producer responsibility and changes in product design. Goal 3 is on waste management and trash capture. Goal 4 is focused on research with a big emphasis on microplastics. Goal 5 is our behavior change goal. And then lastly, goal 6 focuses on fishing and aquaculture gear. And so we are really trying to kind of keep the momentum and continue to engage the partners. And so we have regular webinars and newsletters every 6 months, and we're planning an in-person workshop next summer. And so I encourage, feel free to give me your email address, or there's on the OPC Ocean Litter Strategy website, there's ways to sign up and join our listserv to get announcements about those activities. And so I'll just wrap up by saying that this isn't an issue that any one organization or startup can really tackle on their own, but there are a lot of practical things that we can all consider in our everyday lives to make a contribution. First and foremost, educating yourself on the issues, and I think as consumers who have the luxury of choosing alternatives to single-use items, we can really exercise our purchasing power and be part of this cultural shift towards reusable and refillable items. So things like exploring the bulk section of your grocery store and bringing your own container. I'm sure these are things that a lot of you guys already do. As well as at an institutional level, hosting zero waste events, which it's great to see that you guys do here. And coming out of the San Francisco Bay study, the influence of green infrastructure and rain gardens and the impact that can have on capturing plastics in stormwater, I think is really good to see that there are some practical solutions there. And then lastly, there's an opportunity to get involved in some of these citizen science efforts to help us better understand the issue and the types of debris that are out there. So with that, thanks again, and I really look forward to a discussion. Yes?
So I was wondering whether the agencies have had a very obvious pushback from the plastic manufacturers.
It probably depends what agency you're asking about. At the federal level, we do maintain good partnerships with the plastic industry, and I think in recent years there have been a lot of voluntary commitments by groups like Coca-Cola and Nestle to really increase the recycled content of their materials. I think that's a good place to start, but probably not the best place to stop. And I think a lot of the policy change that we've seen has been sort of maybe at the state level in California and more at the local level in other regions. So they're definitely at the table and paying attention to this issue. Interestingly, I was at a seminar for the San Francisco Bay study just last week. They were kind of rolling out the results of that, and there was in the news, some of you probably saw that the tire particles announcement, and I think they said it was like less than an hour after those news stories went out, they got emails from the tire manufacturers. So this is definitely something that, you know, is on the radar for industry. Yeah. Yes?
If you successfully get all the garbage, especially the plastic, and then get it to the right location to, I guess, recycle, well, what does the ideal recycled plastic product look like? Does it come out as a cube, or you know, what does a recovery plant produce? I don't know.
Yeah. So this is kind of, I'm not a recycling expert, but they, you know, there is kind of this concept of downcycling, and where, you know, you lose the quality of the material. But I think that they go back into kind of those pellets that are the same as the pre-production. So I think it's sort of the same process, where then you try to create like a commodity that can be used to manufacture other goods. But yeah, I would have to look further into that. And there's also a lot of talk recently about chemical recycling, which, you know, I think it's not quite ready for the market or up to scale yet, but there are new technologies that are enabling, you know, any, like, even if it's dirty, contaminated plastic, to be broken down into its, you know, chemical components and turned back into, like, essentially something that's just as good as raw plastic. So, you know, I think that's another thing that the industry is really investing in right now, is looking at those technologies. Yes?
Yeah, can you clarify your 1% number a little bit more? I believe when you mentioned that, you also mentioned the 8 million tons of plastic a year. So plastic goes into the ocean, does it float there forever? And is the 1% of the full amount of time that we've been, or is it just for the year? And, you know.
I think the 1% is like a snapshot of what's there at any given moment, based on the data that's available. That had, you know, when they've kind of extrapolated and estimated how much plastic is floating at the sea surface at any given moment. Your question is a really good one, and one that, you know, I think really depends on the polymer type and, you know, the specific environment it's in. Is it being biofouled? And just kind of understanding where plastic goes once it ends up in the environment is a big remaining question. Yeah. Yes.
I was kind of surprised at one of the slides that shows incineration, the increase in rate of that, because that's almost 50% in the plastic. And I was really surprised by that, and wondered, you know, is that the best use? It seems like there's a lot of precious material in plastic, and to incinerate it.
Yeah, incineration I think is pretty controversial, and, you know, there are a lot of concerns about, like, dioxins and other things that are released when you incinerate plastic. In some cases, you know, it is the best available option, I think. You know, like in island nations that don't have other, you know, they don't have space for landfills, and exporting that kind of stuff is really expensive. So yeah, I'm not exactly sure. I'd have to dig into that paper again to see what they, you know, how they projected that much increase in incineration. But it is a really good point, and there's a lot of groups that are actively fighting against incineration of plastic. Yes, in the back.
I feel like a question a lot of times that people have that, you know, about issues like this, you know, is obviously there's going to be things that we all are going to want from the manufacturers and for like governmental policy. And a lot of people, you know, you can start to accumulate good habits, like you were talking about, whole section things, but I guess, like, what if some random person were to come up to you and ask, like, what's the biggest thing that I could do, my biggest bang for my buck, to try to reduce plastics at an individual level? Is it maybe just those single-use plastics? It seems like that's a big part of it, or are there, you know, other things that we can kind of spread the word about?
Yeah, I mean, I think in terms of the biggest opportunity for changes, the single-use plastics are your biggest bang for your buck. I mean, obviously just, our entire consumer culture in general, like, with all of the new devices that we have to replace all the time, and there's just a big cost to that. But yeah, I mean, I think single-use plastics is where we really kind of focus our messaging. Yeah. And yeah, I mean, there's, opportunities to just kind of start with like one small thing, like we saw the big push for getting rid of plastic straws recently, which, that those in our data sets kind of account for like 1% of the items that we're seeing in the environment. So, it's not a huge chunk, but it is a part of it, and I think it gets people thinking about kind of other things that they don't necessarily need to be using. Yeah. Yes.
At the university level,
Where do we sit with regard to pipette tips, centrifuge, snap vials, sample jars, disposable columns, Hyogen kits?
Yeah.
Good God.
I mean, so I come from the trace metal world, and I'm used to so much plastic waste from those activities. So I really don't know like what contribution.
What would be the right thing
For us to do from a lab point of view. When students come in my lab and they want to be extra clean, they shoot up 120 pipette tips in a row, thinking that the analysis was a lot better because I changed the tip every time. When in fact they're wrong, they should have just kept the same one. But should I worry about that? Should we have a system?
That's a really good question. I mean, I think that it's good that you're asking those questions, and maybe I think you would probably be the better person to come up with an effective system. But one thing that your question reminded me of is that the California State University system-wide last year passed policies to tackle different single-use disposable items like at their food vendors. So I don't know if Moss Landing has a food vendor on site, but for the campuses that do, they are going to be phasing out, I forget exactly which items it is, but they're phasing out like water bottles and plastic utensils and stuff like that over the next couple years. So that's really awesome to see, and I haven't heard of any other university system with like an entire system of campuses doing anything like that. So John.
I completely agree, but I would hazard to guess that compared to a single use in the medical field, research is probably pretty minimal. But that said, like while I've been doing genetics, I have seen from our vendors some efforts to minimize plastic waste. So like this pipette tips used to come in individual boxes. Like the box was much more plastic than the tips contained in the box. And then they came in racks, and then the racks came in, like, instead of a stack of racks, they became just plates with tips that you could then, they figured, ingenious ways to eject the whole plate of tips into a reusable box. And so I have seen some efforts in our field to reduce waste, but we do throw away a lot of plastic.
Do you know, there was a bill that was going through the state Senate, I think it was SB 54. Do you know what happened with that and why?
My understanding is that
Require recycling of plastic.
Yeah, so it was basically this bill that would require any goods that are sold in California to meet I think it was like a phased-in increase for recyclability. So it is kind of a form of extended producer responsibility where the producers of the materials are responsible for the recovery. And what I heard is that, so it's a 2-year bill, so it's going to be considered again in the next session. So I think there's going to be a lot of energy around getting that bill passed. But I don't think it never even came to a vote before the end of the session that ended like a few weeks ago. So yeah.
But it will be brought up in the next.
Yes, yeah. So that'll be really interesting to follow. Yeah.
I'm just kind of curious, like, how much of this problem eliminates from us essentially exporting all of our plastics to be recycled, and maybe not being able to knew that the recycling industry is not particularly profitable, but would there be ways to make it more profitable and have it on our own soil? Some people feel more responsibility for it, or maybe have some operation, or just care about it.
Yeah, it's a good question about, I don't think I've never seen any data on, when we were shipping all of our recycling, which is very contaminated and dirty and not very valuable, like how much of that actually got recycled in, the nations in Southeast Asia where it was going versus going elsewhere, and potentially part of that influx from Asia, how much of that was actually our waste. It's an interesting question, and I wish that there was data on that. And in terms of recycling at home, I think that is something that is being recognized, that we really need to beef up recycling infrastructure domestically. I don't know details, but I think Gavin Newsom just signed a bill for investment for California to invest more in domestic recycling infrastructure. And
Never been able to find anywhere to recycle a bottle within 40 minutes of my home.
yeah.
I have no idea what you're supposed to do.
Yep. Yeah. It's definitely it's definitely an issue, and I think from various places I've heard, a lot of our problems with recycling stem back to like in the early 90s when we switched to single stream recycling, where we used to separate our paper from our glass from our aluminum, and that created more valuable commodities that there were good markets for. But now that it's all contaminated and we're relying on technology to separate it for us once it gets to the MRF, the materials recovery facilities, it just is kind of a messy system. So, and again, that's just part. I don't think recycling is the answer to this problem anyway. So it's definitely part of the solution, but not where I think we should be focusing a lot of the effort. So. Yeah.
I've also always wondered about, and you may or may not know the answer to this question, but there has been like an influx of single-use items that say they're compostable.
Mm-hmm.
And it's a lot of times I've heard that they're not compostable unless they're brought to a specific place. So, I mean, do those often just end up in the landfill and acting like a regular plastic anyways? Is it helpful to create such products?
Yeah, that's another really complicated field. And yeah, so there, a lot of compostable materials, and I think there are better requirements in California on labeling now, but a lot of compostable materials are only compostable in an industrial composting facility. Like you can't put them in your backyard compost pile and expect them to break down. The city of San Francisco recently passed a bill to require, food businesses that are using, or any businesses that are using compostable products have to meet. There's this BPI. I forget what the acronym stands for, but they basically do like a certification for different compostable materials, and so that also addresses like the PFAS and other, nasty chemicals that might be in some of these products. So, again, I mean, people are working on it. It's really complicated, and composting is great, but compostable single-use items are still single-use items. So, yeah, yes.
Just curious from an understand, as you said, based on how much debris is going out in rivers and kind of what's seen, only 1% is what we can recover, and that's primarily single use.
So 1% is what we can account for at the sea surface. Yeah, so we just don't know necessarily where the rest of the plastic is ending up.
So, can we be sure the composition of the rest of the plastic is single use, or is that just the most visible at the sea surface? I'm wondering where the rest of the debris goes, and if there are other plastic sources that need to be targeted. Is it all consumer driven, or is it also plastic waste from industry or from manufacturer, or the pre-production pellets that you talked about?
Yeah, no, that's a good question. So the 1%. It's unclear what the source of that plastic floating at the ocean is. It's just fragments that can't be identified as larger items. But of the materials that you find in monitoring studies, either on land or on the coastline, the identifiable items that you can find are primarily single-use, like food packaging and that kind of thing. So, those are just the majority of the material, the items that we're finding intact in the environment. Did that answer your question? Okay, great. Are we supposed to end at 5? Do people have? Yeah, I mean, I'm happy to answer any additional questions. Yeah.
Where I get really paralyzed by these behavioral decisions I have to make is knowing that changing behavior in one domain has some uncalculated consequences in other domains. So there's plastics, I switch to paper, and now we're cutting down forests and make paper bags instead of a plastic bag. And how do I assess the relative badness of these two impacts that I'm choosing between? And then, and there's myriads of other kind of pathways of consequence that I'm totally unaware of for every choice that I make. So I get paralyzed.
Yeah. No,
Need advice.
not really. I don't know how to tackle that. Economists use life cycle assessments to, compare different materials for the entire life cycle. So from cradle to grave of, this, like whether it's a building material or a type of packaging or something like that. But when you go into those life cycle assessments, you always have to decide what you're most concerned about. Like, are you most concerned about greenhouse gas emissions, or is it, the amount of plastic that's being used? And so it's very complicated. I mean, so, just use less overall, I think, is the easiest approach, but it's, yes?
Do you track research in the use of biopolymers to replace petroleum polymers for plastic? Do you guys get into that at all?
No, we don't. Yeah, we don't really get involved in kind of the materials science kind of things. But similar to the question about compostable materials, they're not necessarily the answer. And a lot of from what I've heard, a lot of the bioplastics still have some of the same like polymer backbones incorporated into there. So there'll be like a starch material, but it's mixed with a little bit of the plastic polymers. So when it gets into the environment, it just breaks down faster, and there's still some component of it that's plastic. Yeah. All right. Well, thank you guys again for the discussion.